Hello students, welcome. Previously, lesson 25, form 3, topic 2, we were dealing with the fourth aim of the direct titration, which was determining the molar mass of the analyte. We have done question number 3. So today, lesson 26, we are going to do question number 4. To read the question, we are told you are provided with solution X containing 3.65 grams hydrochloric acid in 250 centimeter cube of solution. We are given again solution Y containing 5.3 gram of compound Na2A in 250 centimeter cube of solution. So the aim of the practical is we are told you are required to determine the mass of A in the compound of Na2A. The procedure. We are told Romeo 1, fill the burette with solution X. So we are putting solution X in the burette. Then Romeo 2, using a pipette and a pipette filler, we are supposed to place 25 centimeter cube of solution Y in a conical flask. Then we add 2 drops of methyl orange indicator. Then the third procedure is titrate solution Y with the solution X, and we are told record your result in the table below. Romeo 4, we are told repeat the above procedure 2 more times and record the results. So we are given volume of the pipette used, it's 25.0 centimeter cube, and we are having here the titration table. Okay, we are having 3 titrants, then we are having the volume of solution X used in centimeter cube. So Romeo A of the question we are told calculate, but Romeo 1, the average volume of solution X used. So here they have done 3 titrations, and all the 3 titrants have the same value. That means they're in the range of plus or minus 0.2. So that means we can add the 3 and divide it by 3 so that we get the average volume of solution X used. So we are going to say this will be equal to 25.0, which is the first titrant, plus 25.0, which is the second titrant, plus 25.0, which is the third titrant, divided by the 3 titrants. We are told to get average. So this will be equal to 25. We are going to get 25.0 centimeter cube as our average volume of solution X used. So that is part A, Romeo 1. Then we go next. We are told the molar concentration of solution X. Then we are given the Rm of chlorine to be 35.5, then the Rm of hydrogen to be 1.0. To get molar concentration of solution X, we are supposed to first of all know what we are given on solution X. So solution X, we are given the mass of hydrochloric acid in 250 centimeter cube of solution. So what is molar concentration? That's just you been told to look for molarity. So that means we can look our concentration of this solution X in grams per liter. So we are given here 3.65 grams of hydrochloric acid, which has been dissolved in 250 centimeter cube of solution. So we can say if 3.65 grams of hydrochloric acid has been dissolved in 250 centimeter cube of solution, what about 1000 centimeter cube? What mass are we going to get? So that mass that we are going to get there will be in grams per liter. So it will be 3.65 multiplied by 1000 divided by 250. So here we are going to get 14.6 grams per liter. That will be the concentration of hydrochloric acid in grams per liter. So next we have to look for the RFM of hydrochloric acid. We will get RFM of hydrochloric acid. So the RM of hydrogen is 1, plus the one for chlorine is 35.5. Here we are going to get 36.5. Okay. Then next, let's look for molarity. What is the formula for calculating molarity? Molarity is given by concentration in grams per liter, or you can say mass in grams per liter, concentration in grams per liter over the RFM. So this will be equal to, what's our concentration in grams per liter? It's 14.6, which we have gotten, divided by the RFM of hydrochloric acid, which we have gotten here as 36.5. So if we put this one in the calculator, we are going to get 0.4 mole. That's our molarity. Okay, remember, we have the formula for calculating molarity, which is equal to concentration in gram per liter over the RFM. Okay, we move next. Next, we are given the concentration. We are told to calculate the concentration of a solution Y in grams per liter. So what information are we given on solution Y? We are given 5.3 of that solution Y, which has been dissolved in 250 centimeter cube of solution. So if they're asking us the concentration of solution Y in grams per liter, we said if 5.3 grams can dissolve in 250 centimeter cube of solution, what about 1000 will give us the answer? So we are going to say 5.3 grams of that solution Y has been dissolved in 250 centimeter cube of distilled water. So what about 1000 centimeter cube? So we are going to cross multiply, and we are going to have 5.3 multiplied by 1000, then divided by 250. So here, what are we going to get? We are going to get 21.2 grams per liter. So this will be the concentration of solution Y in grams per decimeter cube. So next, we are going to move to part B, and in part B, we are told, given the ratio of the reaction between solution X and solution Y is 2:1. So Romeo 1, we are told determine the molar concentration of solution Y. So we are supposed to look for the concentration or the molarity of solution Y. But the information that we are given on solution Y, we cannot use to calculate the molarity. So we have to use the other way around by looking the number of moles of hydrochloric acid, so that we use mole ratio to calculate the number of moles of solution Y. Then thereafter, look for the molarity by using the formula moles that we have gotten now multiplied by 1000 divided by the volume of solution Y used, which we are given here in the by bits. So 25 centimeter cube of solution Y. So what information do we have on hydrochloric acid or that solution X? We have it is molarity, because we have calculated the molarity of solution X here, and we have gotten 0.1 mole. And we have the volume of solution X as 25.0 in the average titer. So that means if we have the molarity and we have the volume of solution X, that means we can get the number of moles of solution X. So we are going to say number of moles. We are going to say moles will be equal to moles of solution X will be equal to the molarity of solution X, which we have gotten 0.4, multiplied by the volume of solution X, which we have gotten 25.0 in the average titer. Then we divide by 1000. What are we going to get? We are going to get 0.01 moles of solution X, which is hydrochloric acid. Then next, I have to use mole ratio, but they have given the mole ratio between solution X versus solution Y. It is 2:1. But we have gotten the number of moles of solution X, which was hydrochloric acid, to be 0.01 moles. So we can ask ourselves, what about the number of moles of solution Y? So there, we are going to say 0.01 times 1 divided by 2, and here we are going to get 0.005 moles of solution Y. Okay, next, we have gotten the number of moles of solution Y. Then thereafter, we can get the molarity of solution Y. Molarity. So molarity is given by the formula moles of solution Y multiplied by 1000, then divided by the volume used. So the moles of solution Y is this one, 0.005, multiplied by 1000, which is in the formula, divided by the volume used, which is 25. Remember, the volume of solution Y was in the by bit, and you are told place 25 centimeter cube of solution Y. That's what we are told. So here we are going to get the molarity as 0.2 mole. It's M capital letter. So we have gotten the molar concentration of solution Y. We proceed next. What have we been told? We are told Romeo 2, B Romeo 2, determine the molar mass of solid Y. The molar mass of solid Y means the RFM of solid Y, and thereafter you work out the molar mass of A in the compound Na2A. So we have to proceed to RFM. So what is the formula for calculating RFM? RFM is given by concentration in grams per liter over that molarity. This is the formula for getting RFM. So what is our concentration of solution Y? We have gotten that long time ago. We have gotten 21.2. Remember here I told determine the concentration of solution Y in grams per liter. So it is 21.2 grams per liter. So what about the molarity of solution Y? We have gotten the molarity of solution Y here. We are told determine the molar concentration of solution Y. We have gotten 0.2. So that means we can substitute our figures and we say this will be equal to 21.2, which is our concentration in gram per liter, over the RFM, over the molarity, which is 0.2. So here we are going to get RFM of 106. So if we have our RFM of solution Y, or the RFM of solid Y to be 106. So what is the molar mass of solid A, or molar mass of A in the compound Na2A? So we are going to say Na2A will be equal to 106. Okay, then Na, we have its relative atomic mass to be 23. We multiply it by 2 plus A will be equal to 106. So this one, it is 46 plus A will be equal to 106. That means A will be equal to 106 minus 46. So A, we are going to get 60. So that will be the molar mass of A is 60. That's the end of our lesson.